Okay, we're off to a third video on undetermined coefficients. The very first thing you should do is look at this differential equation and convince yourself that this differential equation is not separable. We cannot write the right-hand side as a product of a function of y and a function of t. Stop, put me on pause, think about it. And now that you've thought about it, we realize we can't do separation. Undetermined coefficients is a perfectly good technique. So let's write down the homogeneous differential equation. And again, the homogeneous differential equation has a very fast, easy solution. You can get there a number of different ways. I leave it to you to go figure that out. The particular solution, on the other hand, remember, what we do for the particular solution is we make a guess that the solution is going to look the exact same, it's going to look like the exact same type of function as the non-homogeneity. So in this case, my non-homogeneity is a trig function. Now there's some quirk here because with trig functions, I know that derivative of sine is cosine, derivative of cosine is negative sine. And since I'm dealing with derivatives here, I want to leave myself the out to say my particular solution is not just the sine function, but it is a linear combination of sines and cosines. And that's again because when we take derivatives, the cosines turn into sines and the sines turn into cosines. So I'm going to take this linear combination, but I want you to notice that the frequency on these trig functions is the same as the frequency for the non-homogeneity. That's not a mistake. That's what we're intending to do. The amplitudes, on the other hand, we don't quite know. Okay, so we have our homogeneous solution. We have our particular solution. So what that tells me is that the actual solution to the differential equation, the analytic solution, is CE to the 3t plus, I'll call that C naught actually now, plus C1 sine of 2t plus C2 cosine of 2t. And now I'm going to use the initial condition, which is y of 0 is equal to 1, and the differential equation, which is y prime equals 3y plus 5 sine of 2t. And I'm going to tease out the three different coefficients. So the three coefficients, the C0, the C1, and the C2, are the undetermined coefficients that we're after. So let's tackle them one at a time here. If I use the initial condition, that tells me to put in 0 for t. I'm going to get 1 out for y. So 1 equals C0 times 1 plus C1 times sine of 0 plus C2 times cosine of 0. And just remembering a little bit of our trig, that tells me that I have 1 equals C0 plus C2. So I have a nice relationship between two of the coefficients. Now, we did this before in other videos. Let's recap. If I were to put the homogeneous solution in to the differential equation, I would exactly satisfy that piece of the differential equation and not the non-homogeneity. So the homogeneous piece seems like kind of a frivolous one to put in there. Instead, what I'm going to do is I'm going to put the particular piece in. So again, my differential equation, or again, my particular piece goes into the differential equation. So if I take the derivative of that thing, here, let's look at all this. If I take the derivative of the homogeneous piece, I have 2 C1 cosine 2t minus 2 C2 sine of 2t equals 3 times C1 sine 2t plus C2 cosine of 2t plus 5 sine of 2t. And let's just go piece by piece. That guy right there is y prime. This guy right here is my 3y. And the 5 sine 2t is the 5 sine 2t. All I did was put the particular solution into all the individual places. Now it's a matter of gathering all my like terms and just making sure that everything's kind of hunky-dory here. So I'm just going to rearrange and say 0 equals. I'm going to move everything over to the right-hand side. And I'm going to do so while gathering all of my like terms. So let's look at all of the cosine terms first of all. So I've got 3c2 minus 2c1 on my cosine terms. Pause me and double check my algebra. Plus I have 3c1 plus 2c2 on my sine terms. Oops, shoot, and I completely forgot something. Let's try that again. My sine terms have a few more things coming on. I have a plus 5 also for my sine terms. Right? I forgot this plus 5 right here. Okay, well now if this equals 0 is going to be true for all time, that means that 3c2 minus 2c1 has to be 0. So in other words, the coefficient of the cosine has to be 0. And 3c1 plus 2c2 plus 5 has to be 0. And I also have c0 plus c2 equals 1. And now I have a system of 3 equations and 3 unknowns I have to solve. Okay, well, we can totally do that. The last one's relatively straightforward. The last one, hopefully it's relatively obvious. I can write c0 is equal to 1 minus c2. So once I get c2 nailed down, c0 is going to be relatively easy. The other two, on the other hand, I'm going to rewrite as a matrix equation. So the first one is negative 2c1 plus 3c2 equals 0. And then the second one is 3c1, 2c2 equals negative 5, which I can then augment that. There's lots of ways to solve this system. It's 2 by 2, so I mean really whatever way you think is best. Matrices are just so elegantly simple, I'm just going to go with it. And I can row reduce this guy. So I get 1, negative 3 halves 0. Right, so to do my first step of row reduction, I just divided by negative 2 and got my first row down to something nice. Now I'm going to clear out that 3, so I'm going to multiply the top row by negative 3 and add. And now the fractions are going to get a little bit hairy, but that's okay. I'm all right with that. So I'm going to multiply, let's see here, I got negative 3 halves times negative 3, and I'm going to add that to 2. Okay, so that's 9 halves plus 2. 2 is 4 halves. So that's 13 halves. And negative 5. Double check my arithmetic on this, please. Make sure that I'm doing everything okay. All right, simplify just a smidge more. So 1, 0. I'm going to make this guy a 1 now. I'm just trying to solve that system of equations. So let's see, that's going to be negative 10 over 13. And so last but not least, I need to make that spot a 0. Okay, so I'm going to multiply by 3 halves and add. Okay, so I'm going to multiply that by 3 halves. So that's negative 10 over 13 times 3 halves. which is going to simplify to, let's see, the 3's cancel, so that comes down to -5. Okay, so I got C1 equals -5, C2 equals -10/13, and C0, which is 1 minus C2, if I remember correctly. So that's 1 plus 10/13, which is 23/13. Oops, 26/13. Okay, so I have my solution. Now, the algebra, don't get lost in the algebra here. Put me on pause and go back and rewind. I had, oops, I shouldn't do plus. Let's do minus 5 sine of 2t plus 26/13 cosine of 2t. All right, don't get lost in all the algebra. I did a bunch of row reductions just because that was the simplest way to solve the system. All right, but really all we were doing was setting this piece to 0, the coefficient of the cosine, and this piece to 0, which is the coefficient of the sine. Okay, go back and redo the algebra